Professor Anish Vora, and I welcome you all in this video lecture. In this video lecture, we will study about binary subtraction. First of all, let us see certain rules we have to follow while doing binary subtraction. We have two binary bits, we have A as well as B, and we have difference, that is A minus B. We are subtracting B from the A. Now depends on value of either A or B. If A is greater than B, then we can easily subtract A minus B. But in certain case, if we have B greater than A, then we have to borrow the value from the next bit. So before we start our rules, one thing should be very much clear in your mind, that in binary we have only two bits, that is either 0 or 1. 1 is greater than 0 and 0 is smaller than 1. That should be very much clear. So we have first condition, that is 0 0. So 0 minus 0. So both values are equal, 0 0. So difference is 0 and we do not need any borrow, right? So second condition, that is 1 0. 1 minus 0, 1 is greater, so 1 minus 0, difference is 1 and we do not need any borrow. Then 1 minus 1, again we have similar values, so 1 minus 1, so difference is 0 and again we do not require any borrow. The last condition, that is 0 minus 1. In subtraction, this condition is very important because 0 is smaller value and 1 is a larger value. So 0 minus 1, so that is difference is 1, but at the same time, because 0 is a smaller value, we have to take the borrow. So difference is 1 and borrow is also 1. So this condition is very important and you should always remember this condition. Let us slightly elaborate our rules for binary subtraction. So 0 minus 0, when both the values are equal, the difference is always 0. That is very clear. So 0 minus 0, that is 0. No need of borrow. 1 minus 0. Now 1 is a larger value. So 1 minus 0, obviously the difference is 1. 1 minus 1. As we discussed earlier, in case of similar values, difference is always 0. So 1 minus 1, that is 0. And the last condition, that is 0 minus 1. Now we have already discussed that 0 is a smaller value and 1 is a larger value. So 0 minus 1, so that is 1 and we require borrow. So this condition is very important, and while subtracting you always remember this condition. We have to follow all these rules, but the last condition is very important. Now let us start actually doing certain subtraction. So we have binary values 1 1 and 1 0. So we are subtracting 1 0 from the 1 1. We have two binary values, both have 2 bits. So 1 1 is greater, 1 0 is smaller value. So 1 1 minus 1 0. Now let us apply our rules. We always start our subtraction from the least significant side. So here we have least significant side, and while writing values we have to match least significant side, right? If number of bits are not equal, then we have to match from the least significant side. Now let us apply our rules. So 1 minus 0, we know that it is always a 1, and 1 minus 1, that is 0. We can refer our rules from the table. So answer is 0, 1. But now we have to cross check. If we write equivalent values, equivalent decimal values for 1, 1, we know that value 2 plus 1, so it is 3. Equivalent decimal value for 1, 0, that is 2. And we know that in decimal 3 minus 2, so answer must be 1. So we are getting answer 1. So our subtraction of binary values is correct. Let us take one more example of 3 bit each. We have 2 binary values, and in each binary value we have 3 bit. So we are subtracting 101 from the 111. Now we know that 111 is greater and 101 is smaller value. So let us start subtraction. 111 minus 101, and now we have to apply our rules. So first, from the least significant side, if we start, then 1 minus 1, similar value, so difference is 0. 1 minus 0, it is 1. Again 1 minus 1, similar values, so 0. So we are getting answer, that is 0, 1, 0. But now again, if we require to cross check with equivalent decimal values, then for 1, 1, 1, if we apply 4 to 1, then equivalent value is 7. For 101, equivalent value is 5. So answer 7 minus 5 must be 2. And in binary, we are getting the same answer, that is 0, 1, 0, and that is equivalent to 2. So our subtraction is correct. Every time we need not to cross check with decimal values, but sometime if we need, then we can do. Now let us take one more example. Now we have taken 2 binary values with 4 bit in each value, 4 bit. So we are subtracting 1010 from the 1100. So 1100, that is a greater value, minus 1010. So now again we have to apply the same rules. 0 minus 0, we have equal similar values, so difference must be 0. But now the next is 0, 1. We started from the least significant side, so 0, 0. That was the least significant bit in both the binary values. But now we have 0 minus 1. So now important, now it is very important. 0 minus 1. So 0 is smaller value, 1 is larger value. So we are subtracting a larger value from the smaller. So we require to take a borrow from the next value. So 0 minus 1, if we refer our rules, then 0 minus 1, that is 1. But at the same time, we will have to take a borrow. So 1 borrow we have taken. See, now the next step is very important. You should observe the next step very carefully. We are taking this 1 borrow from this binary value. So we have to subtract this borrow first from this value, and then with the answer we will have to do subtraction with the next value. So it is in 2-step process, right? Let us see. So 1 minus 1, because we have taken 1 borrow. So 1 minus 1. 1 minus 1, both values are similar. So answer is 0. Now again, in the next step, what we do is 0 minus 0. So answer is 0. See, this step or this process of subtraction when we have taken borrow, it is very important. So this should be very much clear, because from this value 1 we have taken borrow. So first we have to take 1 minus 1, and from the answer 1 minus 1 we are getting 0. From the answer we again have to subtract the next bit, that is 0 minus 0. So 1 minus 1, so again we are getting 0. So we are getting answer, that is 0 0 1 0. Now if we require, we can compare, we can take equivalent decimal values and then we can do the subtraction to cross check our answer. Now if we find equivalent decimal values, then for 4 bit we know that we have to follow 8421. So let us take 8421. While calculating equivalent decimal values, we know that where we have value 1, we have to take this value, decimal equivalent value, and we have to do the addition. So in first case we have 1 1 0 0. So we can take 8 plus 4. So 8 plus 4. So we know that equivalent decimal value, that is 12. Same way from 1 0 1 0. So we have 1 at 2 position, that is 8 and 2. So 8 plus 2, so equivalent decimal value is 10. If we subtract 10 minus 12, then in decimal we know that we have values equal to 2. Now let us check with our answer in binary value. Then we have 0 0 1 0. So we have 1 at only one position. So 0 plus 0 plus 2 plus 0. So answer is 2. So what subtraction we have done, that has been cross-checked and verified. So this way we can do the subtraction, we can do the cross verification, but every time we need not to do the cross verification, but rules we should always follow. Now let us take one more example. Now we have taken two values, binary values, that is 110 and 101 minus 100 111. Now both the binary values are of the 6 bit. We can see that both the binary values have 6 bit. So 110 101 is greater value. We have to subtract 100 111 from greater value. So let us start 110 101 minus 100 111. Both the values have 6 bit, so there is no need to match at the least significant bit. It is automatically matched. But when we have different bits in both the values, then we have to match at the least significant side. This is very important. So now let us start our subtraction. But before we start, we should have our table for rules for our ready reference. So we have value A, value B, we have difference D, and we have borrow. So while doing subtraction, initially we have to follow this table of rules. So let us start. So first value, that is 1 minus 1. We always start from the least significant side. So 1 minus 1, then it is a 0. Now second, that is 0 minus 1. So we have to take a borrow, right? So 0 minus 1. So answer or difference is 1, but at the same time we have to take 1 borrow. Now next process is very important. So 1 minus 1, 1 minus 1. So we know that difference is 0 and 0 minus 1. Again, the situation is same. 0 minus 1. So difference is 1 and again we have to take borrow 1. Now again, when we have taken borrow, the subtraction is always in two-step process. So again, we have taken borrow 1 from the 0, right? So first we have to subtract this 1 borrow from the 0. But now we know that again 0 is a smaller value than 1. So 0 minus 1. So again difference is 1, but we have to take borrow 1. So difference is 1. So 1 minus 0. Again 1. But when we subtracted 1 minus 0, we have already taken borrow. So 1 borrow we have taken. Again 1 minus 1. So answer is 0. 0 minus 0. So answer is 0. And last 1 minus 1, and that is 0. So this way we can do the subtraction. We have to take borrow as and when required, and when we have taken borrow, we have to do a process of subtraction in slightly different way, right? So this is very important. Let us take one more example. 110, 111, and we are subtracting 11001 from the bigger value. So now the situation is slightly different. We have 6 bit in our first value, bigger value 110, 111, and we are subtracting 11001. So it has a 5 bit. So now we have to match both the values at the least significant side. So first we write 110, 111 minus second value. But now 11001. We have matched both the values at the least significant side. When we have unequal number of bits, then we have to match both the values at the least significant side. I have repeated for various times because normally it is the point where we do the mistake. So now let us start our subtraction. We have our table of rules for our ready reference. 1 minus 1, 0. 1 minus 0, difference is 1. 1 minus 0, again difference is 1. But now we have 0 minus 1. When we have 0 minus 1, then we have to take borrow. Difference is 1, but at the same time we have to take a borrow. Now when we have taken borrow, the process is in two steps. So first we have to subtract this borrow 1 from the original value 1. So 1 minus 1, so it is 0, and 0 minus 1, again it is condition same, 0 minus 1, so difference is 1 and borrow is 1. So at last 1 minus 1, so answer is 0. So we are getting answer, that is 1110. This 0 on the most significant side, it has no value. So we can eliminate this 0 while writing our answer. If we write 0, then also it has no difference. Now let us take one mixed number, integer as well as fractional, and then how it can be subtracted. So we are taking one value, that is 1011.111 minus 110.01. Now here the point of importance is we have to match fractional points, radix point. Then on the integer side, we have to match a least significant bit. And after a fractional point, for the fractional value, we have to match our bits on the most significant side, right? Let us write and then you can understand it very properly. So 1 0 1 1. Now we have a point, fractional point, and then we have 1 1 1 minus. See, now we have to match at the least significant side. So 1 1 0. See, in first value we have 4 bit in integer values, and in second value we have only 3 bit in integer values. So we have to match these fractional points, as well as we have matched the values from the least significant side. And in fractional value also we have 3 bit in first value, and in second bit we have only 2 values. So we have to match at the fractional point. So this way we can have to write when we have unequal number of bits in mixed values also. So now let us start our subtraction. See, we start from the least significant side. So 1, and here there is no value. So we have to consider it 0, right? There is no value, so it can be a 0. So 1 minus 0, so that is 1. 1 minus 1, similar values, so answer will be 0. And 1 minus 0, so it is always 1. So we have subtracted our fractional values, and then we have our radix point. Then we start for the integer values. So in case of a fractional value, if we require to take a borrow, this borrow can go in integer side also. From fractional side, if we require to take borrow, then it can be from the integer side, right? But here there is no condition, we do not require any borrow. So we start with the integer values. So integer value we start with the 1 minus 0. So 1 minus 0. So answer is 1. 1 minus 1. So answer is 0. 0 minus 1. Now we have a situation. So 0 minus 1. So difference is 1. We have to take a borrow. So borrow 1 we have taken. When we take borrow 1, then process is different. So first we have to subtract borrow, and then from the answer we have to do next subtraction. So 1 minus 1. So answer is 0. Here we do not have any value, so we consider it 0. So 0 minus 0. So answer is 0. So this way we are getting our answer, that is 101.101. So this way we can do subtraction of any binary values. It can be a integer value, it can be a fractional value, it can be a mixed value, it can be a unequal values also, number of in terms of number of bit. So the rule for subtraction that must be clear, especially the condition when we have to take the borrow. I hope you have understood this process of subtraction very properly. Do some practice. Keep watching my video. Thank you very much. Thank you.